In this video, I'm going to explain to you how we can match up atoms, and we'll do this together as a task. So we're matching up the diagram of the atom with the actual periodic table. So if I give you a diagram, I'll start the process off. Let's look at the first diagram that's probably in front of you. You might have a diagram which has got in the nucleus in the middle something like 6 of these things. Can you remember what the plus things are? See if you can remember what the plus things are. Feel free to pause. I'll tell you after the break. Have you had a look? You'll probably remember that the plus things are protons. And I'm also going to draw in 6 of these things without a plus in. And they don't have a charge, but they're also pretty heavy, and we call them neutrons. 1, 2, 3, 4, 5, 6. Just let me finish it off properly. There we go. This whole thing goes in the nucleus, which is in the middle of the atom. I'm also going to draw outside of the atom the electrons. A couple of electrons are going here, and they're orbiting this nucleus. And then you might have to just move this slightly to create a bit more space. I'm then going to go and have a go at drawing the 4 more electrons. And these are sort of out here somewhere, and they're in their own little orbit, the other 4. So the question might be that we ask you, what is the atom? Can you look at your periodic table and work out what atom have I drawn? Have I drawn a sodium atom? Have I drawn a chlorine atom? Have I drawn a neon atom, an argon atom, a mercury atom, a hydrogen atom? What atom have I actually drawn? It may be none of those. Go and have a look, see if you can work it out. Press pause. When you think you've finished, come back. Okay, you're back now. I hope that you said carbon. And the thing that I was looking for with carbon in particular was the fact that carbon has got in it 6 protons. So the number 6 is the number that appears on the top of the box with the carbon. So you would see something like, on your box, if we looked at your box, you would actually see in your box written on the periodic table there's a C for carbon and there's a 6 above. And it's that 6 that's telling you that there's 6 electrons in there. That's the key thing, is the 6. So this number here is basically the number of protons. 1, 2, 3, 4, 5, 6. And you'll probably notice down the bottom there's something written which looks pretty close to 12. May not exactly be 12 because some atoms have slightly different number of neutrons, and that means that there's 6 neutrons as well, because 6 and 6 make 12. And they're the things that give the atom its weight. So if we go and sort of have a look here, we've got 1, 2, 3, 4, 5, 6 neutrons. And round the outside, to balance the nucleus, we've got 6 electrons. But the key thing for you to look at, to work out what kind of atom it is you just count up the number of protons. 1, 2, 3, 4, 5, 6. Look up 6, and 6 is carbon. Let's just try one more so we get the idea. Let's go on a bit of blank, and we'll go and try for us one more. So this time, my atom's going to have just 5 in, not 6. I bet some of you already know what it's going to be just by looking at the 5, and I'm also going to draw in my 6 neutrons. 1, 2, 3, 4, 5, 6. Where we go, and outside that, I'm going to have a couple of electrons here. Draw my dotted line to show that they're going round and round and round. And then we've got another 3 out here. 1, 2, let's pop our third one over there, and another little dotted line. Kind of got to excuse that they're meant to be circles, but they don't really look like circles. Alright, what's this atom? Can you work it out? have a little look at your periodic table and see whether you can come up with an answer. Press pause now. If you want to check your answer, the answer is boron. It's boron. If we have a look, we'll notice there's a 5 up top and there's a number pretty close to 11 at the bottom. 5, 6 more makes 11, and if we go and have a little count up of our number of neutrons, we'll find, let's have a little surprise, 1, 2, 3, 4, 5. There we are. We have our 5 neutrons. And it's as simple as that, going backwards and forwards. Now, what you may be a bit curious about with these various atoms is how are the electrons arranged. And I'm going to go into that in a little bit more detail, but first it's a fairly simple matter for us to create a table so we can draw them in sequence, and that's one of the things we've asked you to do. So go to a new page again, then go and draw up a little table. Let's get our table done. So in our table we're going to just pop down, to save a bit of time we'll just pop the symbol down. You can go and look up the name. So we'll pop the symbol down. We'll write the things from the table. Might have to do a bit of rounding as we go. So we've got our symbol up there, and then we have our number up top, which I'm going to call the Z, which is the atomic number, and that tells you how many protons. There's a number down the bottom, which is the mass or the weight, which is the A, or the atomic mass, and then we'll have our protons, neutrons, and electrons. Neutrons, and finally electrons. So let's start off the process with, first element, hydrogen. What number is it on the periodic table? Have a look, press pause, check when you know your answer. Okay, let's check the answer. 1. That means there's 1 proton and there's 1 electron. Now, if we look at the mass of hydrogen, have a look very closely. It's on the periodic table, it says 1.008. If we round that up, that's just a 1. So that's telling us that the total mass is 1. The mass is is in the nucleus, which are the protons and the neutrons. The electrons don't count as far as the mass goes because they don't really weigh anything at all. So that means there must be 0 neutrons because the overall weight's 1. Let's go to helium. We'll start off with helium. Helium's got a Z of 2 because it's the second element, and it's got a mass of just over 4. So we'll round that to 4.002602, just to 4. We know it's got 2 protons and 2 electrons. We know the rest of the mass is the neutrons. So if we've got 2 protons, so that the protons actually weigh something, whereas these electrons, they don't weigh anything. So if we've got 4 overall, that means we must have 2 neutrons, because our 2 and our 2 make a 4. Let's do lithium. 3. If we round this up, it's 6.94. Round this up, we'll round it up to a 7. We know that's a 3, that's a 3. See if you can guess what that number has to be there. Press pause, come back when you think you know the answer. Let's check the answer. It's 4. Beryllium was the atom I drew earlier up, so it's got a Z of 4. It's got 9 things overall, so that means 4 and 4. See if you can work out what that answer is over there. Let's check. A 5. Carbon we've just done. Carbon is a 6. All up, it's 12, or very close to 12. It's a 6 and a 6, so that's a 6. See if you can keep on now going until the end. I'd like to think that you could get yourself all the way to the end of that line, which leaves you nitrogen, oxygen, and just moving down a page, and you can draw it up more neatly yourself. Fluorine and neon. I won't bother to draw in all the boxes. I'm sure you can extend your table, and you could even keep on going to 20, and then to actually sketch them, it's a fairly simple matter of taking them and actually drawing them out. So let's say we're sketching nitrogen. I'll just give you a bit of time to fill them in first, so have it all filled in. So press pause when you're ready, check again. Okay, you're ready. let's go and fill them in. Let's go and just move this up slightly so we can type them in, or write them in I should say. So let's go 7, this is a 7, that's a 4, 7 and a 7 and a 14, which makes that a 7, and oxygen's an 8, a 16, an 8 and an 8, and therefore I've got to have 8 of them. Fluorine's a more interesting one because it will get slightly different numbers. It's a 9, which means 9 over here, and it's a 19, which means you've got to have 10. So let's go and sketch fluorine, just so you're practicing sketching one. Go to a new page, and it's really now of just drawing them in. So on our new page, first thing we're going to do, we're going to pop in our 9 protons. Let's go and draw them in. 1, 2, 3. Whoops, that doesn't look as good as it could. 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neutrons. You might want to do a double check to check I haven't made a mistake. That's our nucleus. Of course, the nucleus in reality is much, much smaller than what I've drawn. And then some of you may be curious as to how we actually place these electrons in orbitals. And that's, in shells, and that's the last thing that I want to do with you. So the way it works is if we sort of to the side, do a little bit of thinking here. The first shell, which we call the K shell, can only fit 2 electrons maximum in. The next shell, the L shell, can only fit 8, and it really goes on with the shell after that. Even though it can fit 18, you usually stop after 8 and start on filling the next shell and then come back. There's a few weird rules going on. You don't need to worry so much about those rules. Sorry about some of the writing. That should say stop after 8, and that should be an 8, and just make sure it looks like a really good 8. That's a better 8. Okay, so if I've got to place, I've placed 9 protons, so I've got to place 9 electrons, then I'll be able to put 2 in the first shell. So that means I can put 1 and 2, and I've done my first shell. I can't fit any more electrons in that shell. It's like a full bus or a full car. That's the end of it. So I've got 9 altogether. I've done 2, so that means 7 more. So that means in my next shell, I've got 7 more. So if you want to actually draw them very accurately, rather than just scattering the electrons randomly, how many have I drawn so far? 4, 3 more to go to make my 7, and my 2 in the inner shell makes 9. 9 electrons, 9 protons. Let's do a double check and count that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got my 9 electrons, and I'm expecting that to be the same as the number of protons. 1, 2, 3, 4, 5, 6, 7, 8, 9. And because my mass is 19, 9 protons, 10 more makes 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is my sketch of my fluorine atom. You've now got quite a few atoms to sketch, so it's a question of following through. If you're a little bit unclear, rewind this video and see how I did it step by step all the way through, but hopefully it will start to make sense to you, and the more you do, the more confident you'll feel. As far as the rules go, just remember 2 in the first shell, 8, and then you can really think about each shell afterwards being 8, so as you go out, 8 and 8 and 8 again, because even though more electrons will say fit in the M shell, after you get to 8 you still start on the next shell anyway, so it's only if you're dealing with some of the more complicated elements beyond what we're doing this year that you'll really need to be really familiar with how those particular rules are. But if you're looking at the emerging, the foundation or the core levels, then you've really got to remember 2 in the first shell, then 8, then 8. And that's pretty much it. So give the examples a go so you're beginning to feel confident. If you want to draw it really well, do it better than me and don't make your nucleus quite as big, because the nucleus is actually very, 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 very small, as we discussed at the very beginning week. The idea of Ernest Rutherford and his discovery when he bombarded the sheet of gold atoms was that virtually all the particles he sent through went through without bouncing back, which meant that actually atoms are mainly empty space. So the nucleus is really, really small, but if I drew it really, really small, you'd find it hard to see, but I've deliberately not drawn it well. Okay, good luck, and you've got things to get on with.